An Introduction to the History of Mathematics, a revised edition by Howard East, Professor of Mathematics at the University of Maine. To Mims. In fond recollection of countless such things as eating ice cream together in the middle of a lake during the rain. Preface to the revised edition. The very kind and continued reception given to the first edition of this book has encouraged the production of a second edition. Though this second edition is fundamentally the same as the first edition, all those parts of the book that make contact with present time are brought to date. Also, a number of minor historical and typographical corrections have been made, certain passages have been improved, the final chapter has been considerably expanded, and the bibliographies at the ends of the chapters have been brought to date and amplified. One of the pleasantest experiences connected with the first edition was the extensive correspondence received from high school teachers and from high school students. Many of the teachers have instituted in their schools a course in the history of elementary mathematics based upon this book, and a surprising number of high school students have used the book and its problem studies as a source for project material in various courses and in state mathematics and science fairs. It is hoped that the new amplified bibliographies may better serve those folks. It was particularly pleasing to learn that the problem studies have been so widely used to introduce young students to junior mathematical research. Research is perhaps the noblest endeavor of the mathematician, and any young student showing an interest in the subject should, as early as possible, be given some training in research. Of the various ways of accomplishing this, the problem study approach seems generally to be much the best. Some of the research papers produced by high school students from problem studies of this book approach the caliber of a college master's thesis. It is a delight also to express here deep felt thanks to the many college instructors and college students who have used the book, and in particular to all those who took the trouble to write kind words about it. Such letters are veritable vitamin pills to an author. And finally, it is pleasant to express gratitude to Professor Carl B. Boyer of Brooklyn College, whose scholarly comments have done so much to improve the historical accuracy of the second edition. Stillwater, Maine, December 1963. Preface to the first edition. In 1948, while serving on the mathematics staff at Oregon State College, I was asked to develop an undergraduate course in the history of elementary mathematics. Wishing to make the students' participation in the course something more than the usual carrying out of reading assignments capped with a term paper, I conceived the innovation of accompanying problem studies. This injection of some genuine mathematics into the course was carried out with much conviction and not a little trepidation. The result was gratifying. The course flourished in an astonishing and exciting way. It was about this time that my friend Dr. C.V. Newsom urged that the course be written in textbook form. It is a pleasure to acknowledge here the assistance I received from a number of sources. The task of writing the book was considerably lightened by the understanding of the administrative officers of both Oregon State College and Champlain College of the State University of New York. I appreciate this understanding more than words can tell. In a work of this kind, one leans heavily upon the existing scholarly productions in the field. My debt to the historians of mathematics is, of course, immeasurable. I thank the House of John Wiley and Sons of the University of Chicago Press for so kindly allowing me to quote from some of their publications. I wish to acknowledge gratefully the enthusiasm of my students and the work done by Miss Nathalia St. Denis, who painstakingly typed the manuscript for me. I am also grateful for the valuable advice and the numerous suggestions of Dr. M.A. Steiner, who gave so unstingently of his time by critically reading the entire manuscript and by doing yeoman work on the index. But my greatest debt is due to Dr. C.V. Newsom. His encouragement launched the project, and all along the way I was able to benefit from consultations with him. It pleases me to add this preface to that long and growing list of prefaces in which Dr. Newsom's generous assistance is so gratefully acknowledged. Plattsburgh, New York, July 1953. The contents. Part 1, before the 17th century, we'll go over numeral systems, problem studies. Second would be Babylonian and Egyptian mathematics with problem studies. The Pythagorean mathematics with problem studies. Duplication, trisection, and quadrature with problem studies. Euclid's elements with problem studies. Greek mathematics after Euclid, problem studies. Hindu and Arabian mathematics, problem studies. European mathematics from 500 to 1600, problem studies. In Part 2, 17th century and later European mathematics. The dawn of modern mathematics, problem studies. Analytic geometry and other pre-calculus developments, problem studies. The calculus and related concepts, problem studies. And the transition to the 20th century, with a general biography, a chronological table, and answers and suggestions for the solution of the problem studies. Introduction. This book is an attempt to write an introduction to the history of mathematics that can serve as a textbook for a one-semester undergraduate course, which meets 3 hours a week. Consequently, the treatment is restricted principally to elementary mathematics, that is, mathematics through the beginnings of calculus. It is the author's conviction that the history of a subject cannot be appreciated properly without at least a fair acquaintance with the subject itself. The historical material in this book is presented roughly in chronological order, and the reader will find that a knowledge of simple arithmetic and of high school algebra, geometry, and trigonometry is in general sufficient for a proper understanding of the first 9 chapters. A knowledge of the rudiments of plane analytic geometry is needed for Chapter 10, and a knowledge of the basic concepts of the calculus is required for Chapter 11. Any concepts or developments of a more advanced nature appearing in the book are, it is hoped, sufficiently explained at the points where they are introduced. A certain amount of mathematical maturity is desirable, and whether 9, 10, or all 12 chapters are to be covered will depend indeed upon the student's previous preparation. An important innovation in the present treatment is the inclusion of problems. At the end of each chapter will be found a set of problem studies, each problem study containing a number of associated problems and questions. It is felt that by discussing a number of these problem studies in class and working others at home assignments, the course will become more concrete and meaningful for the student, and the student's grasp of a number of historically important concepts will become crystallized. No better appreciation and understanding of number systems can be gained than by actually working with these systems. And rather than just tell a student that the ancient Greeks solved quadratic equations geometrically, let him solve some by the Greek method. In so doing, he will not only thoroughly understand the Greek method, but he will achieve a deeper appreciation of Greek mathematical accomplishment. Thus it is hoped that the student will learn much of his history, as well as some interesting things in mathematics, from these problem studies. Some of the problem studies concern themselves with historically important problems and procedures. Others furnish valuable material for the future teacher of either high school or college mathematics. And still others are purely recreational. Of course, there are many more problem studies than can be covered in any one semester, and they are of varying degrees of difficulty. This will permit an instructor to select problems according to his students' abilities and to vary his assignments from year to year. At the end of the book is a collection of suggestions for the solution of many of the problem studies. There is often some difficulty experienced in pronouncing the Hindu and Arabian names. Some of this difficulty can be circumvented by observing the following accepted equivalents. And then he goes on to give Hindu names, Arabian names, etc. The history of mathematics, even that of elementary mathematics, is so vast that only an introduction to the subject is possible in a one-semester course. The interested student, however, will want to consult further literature. Accordingly, to each chapter has been appended a first bibliography dealing with the material of that chapter. An additional general bibliography given immediately after the final chapter applies to every chapter. It must be realized that the bibliography makes no pretense to completeness and is intended merely to serve as a start in any search for further material. Few periodical references have been furnished. Important references of this sort are very numerous and will soon be encountered by an inquiring student. All references given are accessible and in English. Before the 17th century, Chapter 1, Numerical Systems, Primitive Counting. The concept of number and the process of counting developed so long before the time of recorded history that the manner of this development is largely suspect and conjectural. It is not difficult, though, to imagine how it probably came about. It seems fair to argue that mankind, even in its most primitive times, had some number sense, at least to the extent of recognizing more and less when some objects were added or taken from a small group. For studies have shown that some animals, including other primate species, possessed such a sense. With the gradual evolution of society, simple counting became imperative. A tribe had to know how many members it had and how many enemies, and a man found it necessary to know if his flock of sheep was decreasing in size. Probably the earliest way of keeping an account was by some simple tally method, employing the principle of one-to-one correspondence. In keeping a count on sheep, for example, 1 finger per sheep could be turned under. Counts also could be maintained by making collections, scratches in the dirt or on a stone, by cutting notches in a piece of wood or bone, or by tying knots in a string. These then, perhaps later, an assortment of vocal sounds was developed as a word tally against the number of objects in a small group, and still later, with the refinement of writing, an assortment of symbols was evolved to stand for these numbers. Such an imagined development is supported by reports of anthropologists in their studies of present-day primitive peoples. In the earlier stages of the vocal period of counting, different sounds or words were used. For example, for 2 sheep and 2 men. The abstraction of the common property of 2, represented by some sound considered independently of any concrete association, probably was a long time in arriving. Our present number of words in all likelihood originated and originally referred to sets of searching concrete objects, but these connections, except for that perhaps relating 5 in hand, are now lost to us. Number bases. When it became necessary to make more extensive counts and counting process had to be systematized, this was done by arranging the numbers into convenient basic groups, the size of the groups being largely determined by the matching process employed. Somewhat simply put, the method was like this. Some number, B, was selected as a base, also called radix or scale, for counting, and names were assigned to the numbers, 1, 2, etc. Names for numbers larger than B were then essentially given by combinations of the number names already selected. Since man's fingers furnished such a convenient matching device, it is not surprising that 10 was ultimately chosen far more often than not for the number base B. Consider, for example, our present number words which are formed on 10 as a base. We have the special names 1, 2, all the way going to 10 for the numbers 1, 2, etc. When we come to 11, we say 11, which the philologists tell us derives from ein lefant, meaning 1 left over, or 1 over 10. Similarly, 12 is from twe lif, or 2 over 10, when we have 13, 3 and 10, 14, 4 and 10, up to 19, 9 and 10. Then comes 20, twe tig, or 2 tens, 21, 2 tens and 1, and so on. The word hundred, we are told, comes originally from a term meaning 10 times, or 10 times 10. There is evidence that 2, 3, and 4 have served as primitive number bases. For example, there are natives of Queensland who count 1, 2, 2 and 1, 2 twos much, and some African pygmies count a, oa, ua, oa, 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 a, and oa, oa, oa for 1, 2, 3, 4, 5, and 6. A certain tribe of Tierra del Fuego has its first few number names based on 3, and some South American tribes similarly use 4. As might be expected, the quinary scale, or number system based on 5, was the first scale to be used extensively. To this day, some South American tribes count by hands, 1, 2, 3, 4, hand, hand and 1, and so on. The Yukagirs of Siberia used a mixture scale by counting 1, 2, 3, 3 and 1, 5, 2 threes, 1 more, 2 fours, 10 with 1 missing, 10. German peasant calendars used a quinary scale as late as the year 1800. There is also evidence that 12 may have been used as a base in prehistoric times, chiefly in relation to measurements. Such a base may have been suggested by the approximate number of lunations in a year, or because 12 has many integral fractional parts. At any rate, we have 12 as the number of inches in a foot, ounces in the ancient pound, pence in a shilling, lines in an inch, hours about the clock, months in a year, and the words dozen and gross are used as higher units. The vigesimal system, or number system based on 20, has been widely used and recalls man's barefoot days. This scale was used by Native American peoples and is best known in the well-developed Mayan number system. Celtic traces of a base of 20 are found in the French quatre vingt instead of huitante, and quatre vingt dix instead of nonante. Traces are also found in Gaelic, Danish, and Welsh. The Greenlanders use 1 man for 20, 2 men for 40, and so on. In English, however, we have the frequently used word score. The sexagesimal scale, or number system based on 60, was used by the ancient Babylonians and is still used when measuring time and angles in minutes and seconds. Concerning written number systems, in addition to spoken numbers, finger numbers were at one time widely used. The expression of numbers by various positions of the fingers and hands had the advantage of transcending language differences, but like the vocal numbers, lacked permanence and was not very suitable for performing calculations. We have already mentioned the use of marks and notches as early ways of recording numbers, whether in wood, bone, or other things of that nature. In such devices, we probably have man's first attempt at writing. At any rate, various written number systems gradually evolved from these primitive efforts to make permanent number records. A written number is called a numeral, and we now turn our attention to a simple classification of early numeral systems. Simple grouping systems. Perhaps about the earliest type of numeral system that was developed is that which has been called a simple grouping system, in which a system, some number is B, is selected for number base, and symbols are adopted for 1, B, B2, B3, and so on. Then any number is expressed by using these symbols additively, each symbol being repeated the required number of times. The following illustrations will clarify the underlying principle. A very early example of a simple grouping system is that furnished by the Egyptian hieroglyphics, employed as far back as 3400 BCE and chiefly used by the Egyptians when making inscriptions on stone. Although the hieroglyphs were sometimes used on other writing media than stone, the Egyptians early developed 2 considerably more rapid writing forms for work on papyri, wood, and pottery. The earlier of these forms was a running script known as the hieractic, derived from the hieroglyphic and used by the priesthood. From the hieractic, there later evolved the demotic writing, which was adopted for general use. The hieractic and demotic numeral systems are not of the simple grouping type. The Egyptian hieroglyphic numeral system is based on the scale of 10. The symbol adopted for 1 and the first few powers of 10 are represented by symbols. You have first 1 is a vertical staff, 10 is represented by a heel bone, 10 squared is represented by a scroll, 10 cubed is represented by a lotus flower, 10 to the 4th by a pointing finger, 10 to the 5th by a burbot fish, and 10 to the 6th as a man in astonishment. Any number is now expressed by using these symbols additively, each symbol being repeated the required number of times. And thus you may have the symbol repeated several times in order to have it to make addition problems. We have written this number from left to right, although it was more customary for the Egyptians to actually write from right to left. The early Babylonians, lacking papyri and having little access to suitable stone, resorted principally to clay as a writing medium. You may remember the cuneiform tablets. The inscription was pressed into a clay tablet by a stylus, resulting in the formation of wedge-shaped, or, as has been said, cuneiform characters. The tablet was then baked to a hardness, which resulted in a permanent record. On cuneiform tablets dating from about 2000 BCE to about 200 BCE, numbers less than 60 are expressed by a simple grouping system to base 10. And it is interesting that the writing is often simplified by using a subtractive symbol, the subtractive symbol, and the symbols for 1 and 10. Again, respectively, as examples of written numbers employing these symbols, we have other characters that mark these in the Babylonian cuneiform script. The method employed by the Babylonians for writing larger numbers will be considered in section 1 through 7. The Attic or Herodianic Greek numerals were developed sometime prior to the 3rd century BCE and constitute a simple grouping system to base 10 formed from initial letters of number names. In addition to the symbols that the Greeks had, there is a special symbol for 5. This special symbol is an oath form, the initial letter of the Greek pente, which is 5. And then there's a letter which represents the Greek deca, which is 10. The other symbols can be similarly explained. The symbol for 5 was frequently used both alone and in combination with other symbols in order to shorten number representations. As a final example of a simple grouping system, again to base 10, we have the familiar Roman numerals. Here are the basic symbols, and you can look those up if you want an illustration of that. The subtractive principle, where a symbol for a smaller unit placed before a symbol for a larger unit means the difference of the two units, was only sparingly used in ancient and medieval times. The fuller use of this principle was introduced in modern times. There has been no lack of imagination in the attempts to account for the origins of the Roman number symbols. Among the more plausible explanations acceptable to many authorities on Latin history and epigraphy is that the Roman numerals were derived from the raised fingers of the hand. The symbol X, for example, may be compounded of 2 5s, or may have been suggested by crossed hands or thumbs, or may have originated from the common practice when counting by strokes of crossing groups of 10. There is some evidence that the original symbols for 50, 100, and 1000 may have been the Greek aspirates chi, theta, and phi. Older forms for chi were all of which were used for 50 in early inscriptions. The symbols omega for 100 probably, or not omega, but theta for 100 probably later developed into a somewhat similar symbol C, under the influence of the fact that C is the initial letter of the Latin word centum, or 100. A commonly used earlier symbol for 1000 is also implemented, which could be a variant of phi. The symbol for 1000 became an M, under the influence of the fact that M is the initial letter of the Latin word mille, or for 1000, where we get the word millennium. And of course, C for centennium. 500 being half of 1000 was represented by another symbol, which later became a D. And of course, the symbols for 1500 are found as late as the year 1715.